All right, we're going to be doing part 4 of this August Regents. We have 2 problems to go over. Let's start with our first one. Given circle O, chords AB and CD intersect at E. Okay, so that's just talking about what's drawn here. Now, what we're trying to prove is this theorem over here. If 2 chords intersect in a circle, the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Let's make that, let's clarify that a little. What that's just telling us that is if I had CE and ED, these are the segments of the lengths, and I multiplied them together, that's the product of the segments. So if I took CE and I multiplied that by ED, that would be equal to the product of the segments of my other chord, which would be EB and AE. That's all it's saying. So the product of the segments are equal to each other, okay? So we're going to prove that theorem doing this, exactly what we have written over here. So to do this proof, you just have to make one mental leap and it becomes much easier. And then we pretty much know all the rest from there. So let me just show you what you got to do. What we're actually going to do is prove 2 triangles are similar. We've done that before. But you can't really see that right now. So what you have to do is this, and you're allowed to do this, just connect C and B to make a triangle. And connect A and D to make a triangle. All right? And now we actually have 2 similar triangles here. And we've done this proof before. We know that because we have vertical angles that are congruent here. And remember, C is congruent to A because they both intercept the same arc. All right? So let's prove these 2 triangles are similar, and then I'll take it from there. We'll do a little bit more after that, and we'll see how to end that proof off. So we have statements and reasons. 1, we just copy out our givens. Chords AB and CD, and I'll let you just write the rest on your own, and that's just the given, okay? We got it. Just write the whole given there. Now, 2, what we want to say is this. We actually want to state that we drew those lines. So we're just going to say this. CB and AD are drawn. All right, and all we're going to write here is lines are drawn. Lines are drawn. All right, the reason we do that is because we drew those. I know it sounds like, why would you state that? But you have to state when you drew lines, all right? Now 3, this will get into the proof. Angle CEB is congruent to angle AED. Reason we know that one? Vertical angles are congruent. Okay, 5, let's keep going. Angle C is congruent to angle A. Well, that's 4. Duh. And the reason is here, inscribed angles that intercept the same arc are congruent. Okay, now let's move over here where I have more room. We'll continue our proof. Number 5 is this. Now that we've shown that the 2 angles are congruent, we know triangle CEB is similar to triangle AED, and that's because of angle similarity. And now this is the 2 more steps that we got to do to actually prove the theorem that AE times EB is equal to CE times ED. And here we go. So for number 6, this is what I can state. I know that the ratio of CE to EB, all right, now that's just the 2 sides of my first triangle. So the ratio of CE to EB is going to be the same as my ratio of AE to ED. All right, and that's just the ratios of the other sides of the triangle. So those ratios should be the same, and we know that's true. And we've learned this, and this is because the ratios of corresponding sides in similar triangles is the same. okay? And now that we've got that, we're actually one step away. And I'm not sure if you see what's going on now, but how we can actually make this final proof. But all you'd have to do is this now. You just have to basically cross multiply. And if we cross multiply this, we get CE times ED is equal to AE times EB, right? And that's exactly what we're trying to prove. So for our final thing, how do we know that this was true, what we were trying to prove? Just state that, cross multiply. That's how we got it. And that is our proof right here, and we have proven the theorem there. All right, we just proved that the triangles were similar, and then we did a little cross multiplication. All right, let's move on to our next final question. This one is finding the cost of our snow cone. Let's read it out first, and then we'll just get into it. A snow cone consists of paper cone completely filled with shaved ice, topped with a hemisphere of shaved ice. All right, so what we have is shaved ice. That's not what the color of shaved ice is. We got shaved ice all up in this cone and in this hemisphere. Okay, so that's a composite figure. We have two parts here. The inside diameter of both the cone and the hemisphere is 8.37 centimeters. The height of the cone is 10.2 centimeters. Great, so they give us all our dimensions. The desired density of the shaved ice is 0.697 grams per cubic centimeter, and the cost per kilogram, notice here that there's a mismatch. This is grams, this is kilograms, of the ice is 3.83. Determine and state the cost of the ice needed to make 50 snow cones. All right, so let's just get on paper what we need here. To figure this out, what we're going to do is this. We got to figure out the total volume of this snow cone. So step one is we got to find out the total volume. We're going to find the volume of the whole snow cone. Now to figure out how much this thing costs, we're going to have to figure something out first, and that's to figure out the weight. So then we're going to figure out the weight. And remember, weight is just the density times the volume. And once we found out the weight, we're going to figure out the cost. And to figure out the cost, all we have to do is the weight times the unit price. All right, and we have all that information. The density is given here. Our unit price is given here. All right, so let's just take this 3 steps, nice and easy. Let's find out our volumes. So the first thing we're going to do is we got to find the volume of the cone and the hemisphere. All right. Okay, so the volume first we're going to do is of the cone. Okay, so the volume of a cone is, and this formula is given, 1/3 pi r squared times the height. And all that's given to us. So we know that our radius is just going to be half of 8.3 because that's the diameter. So that's 4.15. So that's 4.15 squared times the height, which is also given 10.2. Just plugging into a formula. If you do that, you would get 183.96. And you should write all the numbers. I'm just going to stop it there. Now, to find our second volume, we got to find the volume of this hemisphere over here. Okay? So that's just half a sphere. So what we're going to do is this. First, find the volume of the sphere. That's 4/3 pi r to the third. Okay? Now we're going to just plug that in. Volume is equal to 4/3 pi times 4.15 to the third. And then whatever that is, I'm going to divide it by 2. If you find out that number and divide it by 2, you get the volume is equal to 149.69. Okay, so we got we got the total volume here. So we just got to add those two together to get it. So our total volume of our ice cream cone, if we add these two numbers together, A and B, we get total volume of this ice cream cone, or the shaved ice cone, whatever you want to call it, is, let's just throw this into the calculator, 183.96 plus 149.69. We get 333.65. And I want to say, I'm rounding a little bit. You guys should not round at all when you're doing a problem like this. Don't put every number you see in your calculator. You don't want to get any rounding errors. All right, so step 1, check. We found our volume. Now we're going to find our weight. So we're going to move on to step 2. And remember, weight, it's an easy calculation. That's just going to be the density, which is times the volume, the total volume, right? So it's 0.697 times 333.65. So our weight is going to be equal to, and I'm just going to put that in the calculator as well, 0.697 times 333.65. And we get 232.554. Okay? There's more numbers. Write them all down. I'm just being lazy. Don't be like me. Well, be like me, but not in this case. So number 3. Now we're going to figure out the cost. All right? Check. The cost is going to be equal to the weight, which is 232.554, times the unit price. Now the problem is this weight is in grams, right? Because we've been working grams. Our price is in kilograms. So we got to convert 3.83 to grams. And we're going to do that by just dividing by 1,000, all right? There's 1,000 grams per kilogram. So when we get that, do that, we get 0.00383. So our cost here, and that's big. Always look for your unit conversions on these problems. They're trying to get you there. 232.554 times 0.00383. And we get 0.89. That's our cost, dollars. So we're almost at the finish line now. All we got to do is say how much 50 would cost. So we're going to take that number, multiply it by 50, and we get 4. We're going to take this number, 0.89 times 50, gives the total cost of $44.53. All right? That is our total final rounded number, the end. All right? So that's all you got to do for this problem. That's it for this Regents. All right, go take a little nap. You did some good work today. Peace.